Hello there, everyone, and welcome back to the Database Design and Implementation lecture series. In this lecture video, I'm going to talk about the course overview. That is, what is the essence of the course? What is the motivation behind this course? And what are the different kinds of topics that we will cover, and why are they important, and what are we going to learn from this course? So let's start with that. Let's start with understanding few of the very important things about a course before we dive into the actual topics that are in the course, right? So before we start, there are certain questions that we should ask ourselves before we start learning anything. So that is what the motivation behind learning a topic is, right? So we should be able to answer three questions. So the first one is basically why this topic. Okay. So that will help us appreciate that what is the goal behind learning this topic? Why do we need it? So in this particular course, the why will correspond to why database design and implementation and its management. Why do we need to learn that? What is the motivation behind that? Right? And once we are able to understand that, the next thing that we need to ask ourselves is basically what topics or contents are we going to learn? Right? So once we are able to appreciate the motivation behind learning the course, what we need to grasp is that what are the different types of topic or contents, course contents, are we going to cover? Right? And then finally, once we have an idea about these first 2 points, then finally what comes is how point number 2 correlates to point number 1. Okay, so this is the agenda of today's video. We are going to try and answer these 3 individual points. That is, why are we learning this subject? What are the topics or the contents that is going to be covered in this subject? And then how does the topics or the contents that we learn relate to the motivation behind learning this particular subject? Okay, so to begin with, let us consider a very specific problem scenario. Okay, a realistic problem scenario that will help us appreciate the importance of this particular subject. So let us take any business, for example. Okay, so let's say you have a business. So say you have a business. Okay, it could be any business. So for example, if you want to relate to something that we are all familiar with and we are dealing with, let us think of this business to be something equivalent to a university, right? It's a non-profit business, but it is still an organization that needs to be run. Okay, so at this point of time, we should all ask ourselves that what are the different activities that goes towards running a university, right? So you have to think about many different aspects. The first and the foremost that comes to your mind, or that should come to your mind, is basically how are you going to allocate your resources. Now, the important thing to note here is that for any organization, for any business, profit or non-profit, you don't have unlimited resources to allocate, whether they are in terms of products, whether they are in terms of, let's say, in this particular example, classroom resources, um, locations that is going to house your classrooms, electronic equipments, chairs, tables, whatever it may be, or even the allocation of finances, right? So that is a big question, that how you're going to allocate your resources, and then how you're going to manage your data. That is all your students in the university, the most important aspect of a university, all its employees, which could be along the lines of faculty, staff, and any other third-party organizations who are employed by the university in order to carry out different kind of tasks. They all have some sort of data associated to them, right? If you think in terms of students, it could be their personal information, it could be their enrollment information, it could be the information about their grades, and so on and so forth, right? Then you can think of faculty, who also has personal informations. They have their degree information, what kind of courses they are responsible for teaching, any kind of financial records, so on and so forth, right? And then you have different domains within the university, which is going to generate different types of data, right? So personal records is something that is specific to each and every entity who belongs to the university environment. But then you have the library system, which will generate its own type of data, right? And then you will have individual departments who will generate their own data. So then the question is, when you are running a business, right? And you can think of these in terms of other businesses as well. Let's say you're running a inventory management organization, or you're running a bank, right? Or you're trying to open your own startup companies. What are the things that matter? So the first aspect is the allocation of resources. And the second aspect is the management of data in a structured fashion. Okay. So all of these leads to a very important aspect of any business, right? So that important aspect is, in order to be successful, any business needs to have good decision making. Okay. And the concept of decision making comes from the data that is stored. Okay. So of course this dependency is going to be the other way around. Okay. So that means that the data that is stored helps in good decision making. So what that means is that the more the more efficiently you are able to store your data, you will be able to generate good information on which you can make good decisions. And if you make good decisions, then your business will be more and more successful. So that means for all the different domains within the university, if you are able to manage your data well, then basically you will be able to efficiently and effectively allocate the resources which are limited. Right? So all of this aspects within such a problem scenario goes back to this simple concept. Is like, how are you going to store, manage, and act upon your data, right? So to recap that and write it down is how to store your data, how to manage it, and then make decision by transforming data into information. Okay, so these are the essential aspects of any successful business that you would like to run. All right. So data is like the currency of running a good business, in a figurative way of saying it. Okay. So then comes the next topic. So what do you need for all of this? In order to make this happen, you have to make sure that you are able to do all of those three things that we talked about in this previous slide. That is how you can store the data, how you can manage them, and then how you can use that to make decision by transforming data into information. Okay, so for that, what we need is to answer the question to what topics are we going to learn in this course that are going to help us achieve those three tasks that we just talked about, right? And that's where comes the course of database design, implementation, and management. Okay, so database are basically computer structures which helps us store our data in a structured fashion, and then we can write queries against those storage units that we have generated within the database, which are known as tables or entities, in order to generate the information, right? So if you have developed a software before, right, or any worked on any internship where you have been responsible for developing an application or a software, right, you have heard in software engineering terms before, and even if you have not taken the course, there is a thing called SDLC, okay, which is known as the software development lifecycle. So that is like the step-by-step heuristical approaches that you need to follow in order to design and develop good softwares. Okay. So similarly, in order to be able to design, develop, implement, and manage good database systems, we have what is known as the DBLC, okay, which is the database lifecycle. All right, which has a lot of similarities with SDLC, but in its own way. Okay, so for any program similar to that in databases, you have to be able to conceptualize your database, okay, which essentially means that you should be able to know how to design, and then of course you need to know how to implement, and then finally manage it. Okay, so that is the goal of DBLC, in order to establish good heuristic approaches that helps us to design a database, to implement it, and then finally make sure manage it, right? So That is similar to like any program that you write. Before you write a program, you try to understand what is the scope of your problem that you're trying to solve with your program, right? So that means like, okay, you're trying to sort a deck of cards. That is your problem scope. So similar to that, within the database environment, you have to first understand what is the scope of your problem. So here, the scope of our problem will be determined by this why. Okay, you have to ask yourself and understand your motivation. So here, if you're trying to design a database for a university, then your conceptual needs are going to differ from a database that you're going to design for, let's say, a banking system, or let's say you're trying to develop for a startup coffee shop, right? So when you're trying to design a database, the first thing that you have to ask yourself is what is the scope of your problem? And that is known as generating the conceptual design of a database. Okay, so conceptual design later on we will learn as we progress in the course is free of any kind of software or hardware platforms, right? So it is similar to writing the algorithm for a program that you're trying to write in order to solve a particular problem. Okay, so when we are designing the first step, when we are designing a database, the first step is to basically generate what is known as its conceptual design. Okay, then when we move towards the implementation stage, that is when we are trying to implement it, we encounter or we will have what is known as the logical design and the physical design. Okay, so as the name suggests, when we are trying to have or implement the database, the logical design corresponds to selecting a particular software which will be used in order to implement your database, right? In the domain of databases, this is known as a database management system. Okay, and for this particular course, we are going to be learning about the relational database management system, or also known as the RDBMS. Okay. And then finally, when we talk about physical design, then that relates specifically to the type of hardware platform on which you will be hosting your databases. So as far as this course is concerned, physical design is out of the scope. Okay, we are not going to be delving too much into the physical design of a database. So we will restrict our conversations and our learning to mostly the conceptual design of the database, which is the most important part. As you know, that if you can develop good algorithms, then you are bound to develop good programs. You're bound to. It's not a 100% guarantee, but you may be able to achieve it, right? But if your algorithm is not good and your algorithm is erroneous, then regardless of which programming language you use, you are always going to almost all the times end up with a very ineffective and inefficient implementation, right? So the same thing goes in the database environment as well. The conceptual design is the most important aspect in terms of database design, implementation, and management, right? So you have to make sure that your conceptual design is as robust and as effective as possible, such that when we move to the logical design and start implementing our database design, then it is quite functional. Okay. And then finally, with respect to management, we will come to the topics that we discuss that we are going to cover in order to make sure that our database runs as smoothly as possible. So for that, a few of the things that we have to talk about is basically how do we optimize it. Okay, in terms of its performance, that is how do you take care of the optimizations. All right. So the topics that we are going to cover with respect to the conceptual design is to first understand what data models are. Okay. So of course at the beginning we are going to be covering some topics which helps us understand the evolution of data storage. Okay, so that is like a precursor to getting to the actual database systems, right? But once we get to the database system and we start our journey into developing robust conceptual designs for any kind of databases, given the type of problem scenario that you select, the first thing that we will cover are data models, which is nothing but constructs which gives us an idea of what kind of design principles do we need to follow in order to generate a particular database. So we will learn later on that data models can be of different types, right? You can have hierarchical data models, network data models, and then the one that we will learn throughout the entirety of this course, the relational data model that relies on relational algebra. And then you have the entity relationship model, so on and so forth, right? So that is what we are going to cover first, is like what are the different types of data model and what kind of design constructs do they offer us, okay? And then we will narrow it down to what is known as the relational data model. Okay, so in terms of the functionality of a database, the conceptual design relies on the relational data model. At least that's what we are going to cover in this course, right? So then after that, in order to simplify the graphical representation of our conceptual designs that we come up with, we are going to learn about what is known as the entity relationship model. Okay, so this is known as the entity relationship model. Okay, so the overall goal is, since the relational data model will help us with the fundamental constructs of our conceptual design, but in order to make it graphically simple and in order to convey our ideas to, let's say, our clients, to our audiences, to our managers, whoever it might be, right? We are going to be using what is known as the ERM, which will be built on top of the relational model in order to graphically simplify the representation of our conceptual design. Okay, and then we will supplement that ERM with what is known as the EERM. Okay, which is nothing but enhanced ERM. Okay, so what is enhanced? So in a nutshell, enhanced means like we are trying to introduce the concepts of object-oriented programming to the design constructs of the entity relationship model. Okay, so I hope you all recall the different properties of object-oriented programming. Okay, you had abstraction, encapsulation, inheritance, polymorphism, and so on. So what we are trying to do is, in designing a database, we are trying to incorporate and implement within the conceptual design the properties of abstraction and the properties of inheritance in order to further improve our designs. Okay, whereas this topic of EERM, in addition to introducing or help us learn how to introduce object-oriented concepts, we'll also talk about some of the basic design flaws that you can encounter when you are working on conceptual design and how to avoid them. Okay, so that will mark the end of generating a conceptual design. Okay, but anytime you come up with a algorithm in your programming domain, once you have generated the algorithm, what do you do next? Do you simply go into implementation? If you're working on a realistic project, You should not do that. You should not simply jump into implementation right after you have generated your algorithm, hoping that everything goes well. That is not how you generate a good design. So once you have generated, so at this point, when you reach this point, you will have a conceptual design. Okay. So what comes after that is very important. And again, it draws from the simple programming concepts of software engineering, developing apps, and so on and so forth. Is once you have generated your algorithm, the next thing that you have to make sure is its correctness. Okay, if you have taken the algorithm design and analysis class, then you will see that class specifically deals with validating the efficiency and the performance of the algorithms that you design. So that is what we have to make sure here, that once using all of these topics, once we have come up with a conceptual design, we need to make sure that the design that we have generated by using the relational data model, the entity relationship model, and the enhanced entity relationship model is as robust as possible, and that there is no further scope of improvement in the design. Okay, so in order to do that, we do have a set of techniques within the database environment that helps us perform those correctness, or make sure that the design is as good as possible. And that is the fifth topic, which is related to conceptual design, and that is known as normalization. Okay, so normalizations, you will learn about different normalization techniques that is known as the first normal form, which is also written as 1NF, then the second normal form, the third normal form, and so on. Okay, we will only talk about up till the fourth normal form, but in practicality, most of the practical databases that you have for real world applications are mostly in its third normal form. So we are going to understand that, okay, what is it for a database, or what does it take for a database or a table, not a database in itself, for a table to be in the first normal form. Then how do you transform that to the second normal form, and then to the third normal form? Okay, so there are certain steps, certain constructs which are provided in each of these transformations. So we are going to use those steps, and we're going to apply them to the conceptual design that we have generated by using all of these previous topics. Okay, so to understand it, these first four topics is going to give us a way to generate a conceptual design, and then using normalization, which is also a part of conceptual design of databases, we are going to verify that the conceptual design that we have generated is as robust as possible, and that there is no further scope of improvement. So if there is any further scope of improvement, then the normalization is going to help us achieve that. And that will mark the end of conceptual design techniques. So now if you recall, what comes after design, the conceptual design, within the scope of this course, is the implementation part of your databases, right? Which is also the logical design. So as I mentioned earlier, we are going to be using what is known as the relational database management system as our software to implement all our databases for this course. Okay, so what that means is what follows after the conceptual design is the logical design. And the logical design is all about implementation. So for implementation, we are going to learn two specific topics. The first one is introduction to SQL. And then the second topic is advanced SQL. Okay. SQL stands for what is known as the structured query language. Okay? It is not a programming language as such because it's not procedural. It's a non-procedural programming language, and we will discuss that what is the difference between a procedural programming language and a non-procedural programming language later on when we get to this particular topic. But using SQL, we will be able to implement our database environment according to the conceptual design that we have generated. Okay, that will involve implementing tables, database tables, and the attributes within those tables, inserting data into those tables, and then developing queries that can be run against these data that you have stored in a structured fashion in order to generate information, valuable information based on which decision making can be performed by your organization. Okay, and advanced SQL is going to cover some of the more advanced topics that relates to managing your databases. So you will learn. So the introduction to SQL will basically cover the fundamentals of implementing your database. Okay, and whereas advanced SQL will cover some of the important topics which relates to managing your database. Okay, and it will discuss different topics like how to write procedures, okay, which is nothing but like functions that can be written or prepared before the execution of your database server, and then executed later on when you get inputs from your clients, which needs to be run against your database. It will also help you learn about what is known as SQL triggers, which is nothing but, this is an R and not a V, which will help you understand how to automate some of the table management activities within your database. Okay, and then it will also help you learn about NoSQL, or what is also known as procedural SQL. So like I mentioned a few moments back, is SQL is not actually a language, a procedural language, right? Uh, because you don't have the support of if-else statements, branching statements, and loops, right? But there are certain scenarios with respect to management and decision making where the presence of branching statements and loops are very important, right? And that topic is covered in advanced SQL, is how to write procedural SQL codes that will help you better manage your database environment, right? So this 2 chapters is going to cover how to implement your databases and then how to manage them. Okay, and then finally, with respect to management, or we will call it what is known as other topics relevant to DB management. Okay, so the other topics that we are going to cover here in this section is first of all, we're going to learn about what are database transactions. Okay, and once we learn about that, we are going to learn about transaction management, and then concurrency control. So the first question that should come to us at this point of time is what is a transaction, right? So in short, transactions are basically a set of related queries relevant to a particular logic that you're trying to implement that are grouped together and executed in a single atomic fashion. Okay, so there's a lot of words there, so let's unpack that. So imagine an example where you are trying to implement a website which relies on a database, which is responsible for, let's say, selling products over the internet. Okay, so let's say you're trying to sell a smartphone or a smartwatch or any simple kind of products over the web page, right? So if your action, if your logical action from your customer's side is let's say to buy a product, okay, let's say buy watch. So this is the logical action that your system is trying to implement, which relies on the database, right? So now the question for you is then, what are the set of related, relevant actions your system needs to execute, one after the other, in order to satisfy this particular operation, right? So the first thing that you have to do is you have to reduce. Now, this is assuming that the sale is successful, right? We are not going into the other if-else branching statements, right? So we have to reduce the inventory count. So what does that mean? If you have sold a product, then in your inventory or in your stock, the quantity of the product count reduces, right? So you have to reduce that. Then you have to, let's say, charge the customer account, right? So that means if the customer has an account with your organization, and that information is of course stored in the database, then against that customer, you have to give some credits, right? Or you have to keep a track of the payment, whether the payment is made or not. So that is what charging the customer account uh, on a very high level means, right? But you have some subtasks that you have to execute related to that. And then let's say you have to initiate shipping, right? You have to ship the product because it is an online product selling company, right? You have to find a shipping company, right? And you have to deliver them the product. You have to give them the address, and you have to track that shipment to make sure that it reaches the customer, or whether it got delayed, and so on and so forth. Or did the customer return it, or was it cancelled, right? Or so on and so forth, right? So all these are relevant tasks that is wrapped under this single activity, buying a watch, right, from your e-commerce website, right? So that this action is a transaction. It is a transaction which has a set of related queries which needs to be executed in an atomic fashion. So what that last part means, the atomic fashion, is that all of these activities, that is to reduce the inventory count, charge the customer account, initiate the shipment, for that particular transaction needs to be executed entirely. You cannot execute reducing the inventory count and then not charging the customer. You cannot charge the customer and then not initiate the shipment process, right? So that is how or where transactions differs from simple queries. Okay, all the transaction is a set of relevant queries that needs to be executed as a single logical unit, right? You can execute, when you execute a transaction, you execute all of the queries that is bundled within that transaction, right? So after that comes the topic of transaction management and concurrency control. Okay, since in a realistic environment, you can have multiple customers engaging with your system that relies on your database system or your database server, then there could be a chance that multiple people are trying to access the same database resources concurrently at the same time, right? So think of another example here. Let's say you're buying, in order to understand concurrency control, let's say you're buying concert tickets. Okay, so that means that there is a limited amount of resources that multiple customers are trying to grasp, and they will be coming to your website and they will be trying to pick that particular seat that they desire, right? And at any point of time, if 10 customers come and select this one particular seat, then in your database, you only have a single table that is going to store the seat information and then assign that seat information to another table related to the customer information, right? So now what do you do in such a scenario, right? You cannot sell a single seat to multiple customers, right? That is not practically feasible, right? So how do you manage that? That is the topic of concurrency control, right? Because it is still a transaction, that is, you're trying to buy a seat, right? But there are multiple entities or multiple customers that are trying to lock the same resource, right? So in order to be able to manage that, you have many different algorithms within the domain of concurrency control that will help you manage your database within the topic of transaction executions. Okay, and then after that, the second topic that is there in the other topics that are relevant to database management is basically query optimization and database performance tuning. Okay, so as the name suggests, it's pretty straightforward. Is how do you write better queries? So what we mean by better queries or to optimize the queries is to improve its performance in terms of its execution. As you may recall, that any program that you implement or any algorithm that you design, there is a time complexity with respect to its execution, right? So similarly, when you write a query and when you execute them, there is certain costs that are associated to it with respect to time, with respect to the database resources that it accesses, right? So you cannot write a query wherein if a database requests you, or if a customer requests you, sorry, not a database, if a customer requests you, which needs to be executed against your database, that, hey, what are the nearest restaurants that are open right now from my location? Okay, that could be a transaction as well. Now, if you have written a query on your server that is going to be executed against your database, which returns the result in, let's say, 5 minutes, then your organization or your business is not going to be successful, right? So the goal is to make sure that your queries executes in the least possible times, and that is the objective of this topic, query optimization. Okay, it is going to help us understand how to evaluate the performance of different queries that we write and how to improve them. Okay, and then finally, database performance tuning relates mostly to the physical design aspects of the database. And since we are not going to be talking about physical design, we won't delve too in depth in this particular topic, but we are going to briefly cover what are the different ways in which you can improve the database performance tuning, right? And we are going to look at it from a more of a software perspective than a physical perspective, right? We are going to talk about how we can improve the performance by the use of what is known as database indexes. Indexing is a thing that improves searching. Okay, if you're trying to search for something, and if all of those aspects are indexed, then you can very quickly find it, right? A case in point for this is basically how any library operates. All the books, where they are stored, they're basically indexed. So if you're looking for something, there is an aisle which is for a particular topic, and then you have divisions in that aisle. So if you're looking for a book, you can quickly narrow down to where that particular book is stored. So the same goes for database entries as well. If you have your database indexed in a very effective fashion, then when you execute a query and that query is trying to retrieve some data from your database, then it can do it very fast, right? So instead of talking about physical design, we are going to talk about database indexes, right? What are the different ways in which indexes are implemented in the database, and when are those different methods suitable for what kind of storage purposes, right? Or what kind of data, okay? And then finally, we are going to wrap up the course by learning about a concept that is a bit separate from all these previous concepts that we have talked about, is an introduction to distributed database management systems. Okay, so all of these topics that we will cover here, whether it relates to the logical design or whether it relates to other relevant topics for database management or the conceptual design, they all relate to what is known as centralized database. Okay, what it means is that your database server is all of your data, and your database server is hosted physically in a single geographical region. So now, if you decide to host your databases spread across different geographical regions, then how are you going to implement it and how are you going to manage it? So that is the context of learning about distributed database management systems. So it is going to talk about different techniques to design a distributed DBMS. Okay, so that is how we are going to be wrapping this course up, right? So finally, to look at the third point, when we started, is we talked about why are we learning this subject, right? And then what are the topics or contents that we have or we are going to cover, right? And then finally, the last point which we want to talk about, which we have discussed here in the second point as well, is how the topics that we are going to learn correlates to the first point, which is what is the importance of learning about database design, implementation, and management. So again, to recap the things that we discussed, for any business, okay, whether it be profit or non-profit, for it to be successful, what is important is for it to be able to make good decisions. Okay, good decisions is all about allocating the data, allocating the resources, sorry, not data, that they have. It could be materialistic, non-materialistic, financial allocations, and how to structurally store the data that is generated by all the entities within that ecosystem, right? Because data stored in a structural fashion supports good decision making, right? So the goal of any company or any organization is to be able to store their data effectively, manage it, and then execute queries against that data such that the data can be transformed into information which will help with our decision making, right? Next, we covered the different topics that we are going to cover in this course for database design, implementation, and management. So we talked about the conceptual design of how it's similar to like writing an algorithm for a program. And then we talked about the logical design, which is about the implementation of our databases. So in order to implement the conceptual design, we discussed that we are going to learn these 5 chapters. Okay, and then for logical design, we are going to cover these 2 chapters, which is Introduction to SQL and then Advanced SQL. So for management, Advanced SQL also has certain topics like how to write stored procedures, MySQL triggers, and then learn a bit about procedural SQL as well. And then finally, we are going to cover some other relevant topics in the form of these 2 chapters, which is to learn what is database, where did it go? Here. What is database transactions, and then how to perform query optimization and database performance tuning from a software perspective. And then finally, we are going to be wrapping up this course by discussing or having a brief discussion over how to design distributed database management systems. So that is all for today's video or of this video. And I'm going to be seeing you all again in the next video. Until then, stay safe and take care.